going to continue with numerical approximations to integrals by talking about Simpson's rule. Simpson's rule states that the integral from a to b of f of x dx is equal to, now first I want to say that the number of partitions must be even. Now let's just look at something. If n is 4, for example, that means from a to b, I break it up into 4 intervals. 1, 2, 3, 4. Now, how many endpoints are there? 1, 2, 3, 4, 5. So always one more. It probably would have been better if I counted that one first, and that one second, and that one third, and that one fourth. And then you say, well, what about the first one? It's always one more than n. So the number of endpoints will be odd. Now Simpson's rule states that the integral is not equal to, but is approximately the length of each width divided by 3. That is b minus a over 3n. And then you multiply by f of the left endpoint plus 4 times f of the next endpoint, and then 2 times f of the next endpoint, and then 4 times f of the next endpoint, and then 2 times f of the next endpoint. Other than the first one, the numbers in front oscillate. 4, 2, 4, 2, etc. all the way down to the next to the last one. The last one will be f of xn, and just like the first one, there's no the coefficient in front is 1. Now what is it before the last one? F of xn minus 1. What is that going to, what's the coefficient of that one going to be, you ask? It's going to be 4. It's going to be 4. Now, so in other words, the first and last coefficients will be 1, and then you have 4, 2, 4, 2, a number of times, 4, 2, and then 4. Well, this is odd, because the first and the last, that's 2 of them, and then, which is even, and then you have another even, and another 2 more, and you have pairs in there, 4, 2 is one pair, and then the next 4, 2, and then another 4, 2. So all the ones that are circled or boxed, there is even number of them. Then you have one more, which is odd. And remember, if n is even, you're going to get one more than n. Even if n is odd, you're going to get one more partition, or one more endpoint, The number, whatever the number of partitions are, you will get one more endpoint. And one more than even is odd. So it does start, let's forget the first and the last. It starts with 4 and ends in 4. 4, 2, 4, 2, 4, 2 forever. Of course, at this point, it's time to do a numerical example, or an exact example. Let's close the bracket there. So, how about we try to figure out the integral of x squared dx to approximate the integral of x squared dx, where x goes from 3 to 5. And to save some space, I'll put up here that n is 4. Well, the first thing I would want to do is find out what delta x is. That is, what is b minus a over n? No, why don't we just say what it is? 3n. That's a, that's b. It's 5 minus 3 over 3 times 4, n is 4. It's 2 over 3 times 4. And 2 goes into 2 one time, and into 4 2 times. So we have our sixth. b minus a over 3n is 1/6. Okay. Now, we are going from 3 to 5. Actually, we really do need to know delta x. Right now, we have delta x divided by 3. And delta x is b minus a over 4. It's a quarter. Okay, 3. 2 quarters. 2 quarters, which is a half. So it's 3 and you add a half. 3 1/2, 4, 4 1/2. These are the endpoints. This is above what is called x0. That is, x0 is 3, x1 is 3 1/2, x2 is 4, x3 is 4 1/2, and x4, which is xn, is 5. So what we need to do is calculate f of 3. Now, this here is f of x. You just square, okay? So first I square 3, I get, well, let's write it down as 3 squared. Plus 4 times, now I square 3 1/2. I square 7/2. And then it's 2, and now I square 4. 4, 2, and now it's 4. And now I square 4 1/2, or 9/2. And then the last one is just square that. That is a number in front, doesn't matter. Sorry, the number in front most certainly does matter. It's just the number 1. And let me erase some of this. And let's do these mechanical calculations. This mess is going to equal what I'm writing. It's the integral that'll be approximately what I just circled. But what I circled is 1/6, 9, plus, when you square 7 over 2, you get 49 over 4. That's going to cancel. The 2 squared, that's not 2 in the bottom. It may look like 2, but it's not 2, it's 4. Okay, so it's 49 plus 16 times 2 is 32 plus 81. Because when you square that 2 on the bottom, it's going to kill off the 4 on the top. All that survived was the 9 squared. Plus 25. This plus this is 90. 50. I'll add 1 here, and I'll take away 1 there. That's how I add. I'll get 81. And then I add 25, and I get 196. The answer is 196 divided by the 6 in front. 3 goes into both of these numbers. Actually, they don't. 2 goes into both of these numbers. 98 times over 3. The answer is a little bit less than 33. Now, this is a pretty simple integral. We can find the exact answer. The integral of x squared is x cubed over 3, from 3 to 5. 5 cubed, 125 over to 3. 3 cubed, 27 over 3. This is, in my opinion, very, very highly unusual. But we actually got the correct answer by approximating. That's unusual. In fact, I'm shocked. Okay, let us try another formula, or another problem, excuse me. Why do I think I made an arithmetic mistake to get the exact answer? It's called lucky, coincidental. How about again with n equals 4, nice straight line. We want to integrate, say, x plus 1 dx from, 5 to 6. And again, we'll let n equals 4. Now, we could figure out what this is. We know the y, if y is equal to x plus 1, if x is 0, y is 1. If x is 1, y is 2. There it is. And we want to go from 5 to 6. We want this area. We want the area in here. Okay, this is a trapezoid. This distance, well, just add 1 to x. X is 5 here. This distance is 6. Likewise, this distance is 7. If you want, this is a trapezoid. I could rotate it on its side. I think I can. Oh my. Okay, so this is 6, and this is 7. Well, yeah, that's taller. Well, here it is. Well, I did a terrible job rotating it on its side, didn't I? Okay, piece of cake. This is 7, this is a right angle, this is 6, there is your trapezoid. And this is a right angle. This here is a right angle. These lines are vertical, so is that. Okay, so now you add the two bases, divide by 2, and multiply by the height. The height is 1. This distance is 1. So you get 13 over 2. Times 1 is 13 over 2. Well, I know the exact answer. 6.5. Maybe it would have been quicker to integrate. What do I know? So x plus 1, that's the function. That's the function we're going to use in the Simpson's rule. This is approximately, now, what is b minus a over 3n? Well, first, it's 1/3 of b minus a over n. This way, we can find two answers, and you'll see what I mean in a moment. 1/3, 5 is a, 6 is b. So it's 6 minus 5 over n is 4. That was given. Can't do these if you're not told what n equals. And this is 1/3 times 1/4. Okay. Well, that's delta x. That is, delta x is 1/4. And when you multiply these two, you get a 12th. This is their 12th. That's exactly what goes in front of the integral. 1 over 12. 1 over 12. Okay. So delta x is 1/4. Well, why do we need that? Well, that helps us get the x sub zeros. We are going from 5 to 6. And going from 5 to 6. And delta x is 1/4. So you go 5, you add 1/4, you're 5 1/4. You add another quarter, at 5 1/2. Add another quarter, you're at 5 3/4. Okay, so according to the formula, first I need f of that. Just add 1 to it. The first term, the understood 1 in front. The next term, you take f for 5 1/4, get 6 1/4. Multiply it by 4. 1, 4, 2, 4, 2, 4, 2, etc. It ends in a 4 and then a 1. Next one is 2. You add 1 to this number, get 6 1/2. Plus 4 times f of that number. Just add 1 to it. F of 5 1/2 is 6 3/4. And the last one, you don't multiply by anything. Or if you insist, you multiply by 1. You add 1 to that number, you get 7. Multiply it by 1, it's still 7. So let's see what we got. We have 1 over 12 in front. 1 times 6 is pretty easy. Now remember that 6 1/4 means 6 plus a quarter. You multiply it by 4, you get 24. 4/4 is 1. 25. 2 times 6 is 12. 2 times 1/2 is 1. 2 halves are 1. That gives you 13. Let's multiply 4 by 6 3/4. 4 times 6 is 24. 4 times 3/4 is just 3. So you have 24 plus 3. 27. Plus 7 more. 1 over 12. Love things that add up to 10. 10 and 20 are 30. 3 and 7 make it 40. 25 more, 65. 65 plus 5 is 70, plus 1 more, 71, plus 7 more, 78. So I get 78 over 12. And remember, we got 13 over 2, which is 6 1/2. 12 into 78 goes 6 times. 6 times 12 is 72. This is amazing. And you get 6 more, so you still get 6 1/2. Well, not 6 1/2. So we actually got the same answer again. This is less surprising after quickly thinking about it, because this was just a straight line. There was no errors involved here. But if it was x plus 1 squared or x cubed minus 3x plus 9, you would get some approximation errors. But the bottom line is, this here is the formula. B minus A over 3n, and then you add up f of x0, f to x of x1, f of x2, etc., except that it goes 4 after the first term and the last term. They don't get those heights, those f values don't get multiplied by anything. But the middle terms, it goes 4, 2, 4, 2, 4, 2, 4, 2, for however long. And then it ends in 2, but then you have the 4. That is, the 4, 2, 4, 2, 4, 2 ends in a 2, and then you have a 4. The second term and the second term from the end, the second term from the beginning, the second term from the end must be 4. And it oscillates. 4, 2, 4, 2, 4, 2. But again, it ends in 4. And the first and last terms don't get multiplied by anything. Okay, good luck with this.